Alright, so today in quick recap series we will study about the parallel axis theorem. Alright, parallel axis theorem basically what does this mean? It basically relates the moment of inertia of a rigid body about two parallel axes. Alright, and one of which passes through the center of mass. See, look at this diagram. This is the body, alright, which is having mass m, capital M, and there are two axes. One axis is AB and other axis is XY. Alright, the distance between two axes is R. Right, now we have to calculate the moment of inertia about this axis, this XY. So how we will calculate? We will just use this formula, Ixy equal to Iab, which is this axis, plus mr square, right? And this Iab means the moment of inertia about this axis, and this axis is passing from this point, which is your center of mass. COM means center of mass. So we will basically find the moment of inertia about this axis, and then we will just add mr square, this product, and we will get the moment of inertia about any axis which is at a distance of r from this center axis. So this is basically a parallel axis theorem. Okay, now come to the perpendicular axis theorem. Alright, see, perpendicular axis theorem, it states that the moment of inertia of a plane lamina. What is lamina? Lamina is basically a two-dimensional body, this one. Alright, so we have to calculate the moment of inertia about this axis z. Alright, now how we will calculate? See, the theorem states that the moment of inertia of a plane lamina about an axis perpendicular to the plane of lamina, which is this z axis, is equal to the sum of the moments of inertia of the lamina about two axes perpendicular to each other. This is one axis, axis x, this is another axis y, and both this x and y are the axes which are on the plane of this lamina. Clear? And this z axis, this is perpendicular to the plane, right? So we have to calculate the moment of inertia about this x axis, we have to calculate the moment of inertia along this y axis, right? And condition is that both this axis x and y should intersect at this same point, which is this O, and the z axis around which we have to calculate the moment of inertia, it should also pass through this point O, this intersecting point. Alright, so in its own plane and intersecting each other at the point where the perpendicular axis passes through it. So in this case, the moment of inertia about this z axis will be equal to the moment of inertia around this y axis plus moment of inertia along this y axis and x axis. Clear? Just you have to add the moment of inertia of these two axes, and that will be equal to the moment of inertia around this z axis. So this is your perpendicular axis theorem. Alright, so this is your quick recap series. I hope it is useful for you. So if you like the video, then press the like button, subscribe the channel and share the video. Okay, thanks.